So, chapter 6, normal distribution. So here come the actual words. So the mean amount of time it takes a kidney stone, this is a delightful example, a kidney stone to pass is 15 days. I've never had those, but I've heard they're terrible. It's 15 days, and the standard deviation is 4 days. So the mean, the average, 15 days. Ooh. 15 days is, I guess, the average it takes to pass a kidney stone. But not everybody's average. Standard deviation is 4 days, right? Remember what standard deviation means? Typical amount off the middle, right? So not everybody's exactly middle. You know, how far are they off the middle? On average, they're 4 days off the middle, above or below, right? All right, anyway, suppose that one individual is randomly chosen for how long he or she takes to pass the kidney stone. So what do you think if we graphed everybody who has kidney stones and how long it takes them to pass all their various kidney stones? And if we wanted to Google right now and said, show me a graph, Google, of all the kidney stone data that are in the medical journals, guess what we would find? A bell curve, right? There'd be some average, which they just told us is 15 days. There'd be average time for people to pass kidney stones, 15 days. And then there would be these, then it'd be going down to the right and the left of that as people go longer and longer and shorter to pass their kidney stones. If you're taking, 28 days to pass your kidney stones, you're in the extremely high number, is what we would find. And if you're only taking 5 days to pass your kidney stone, you're getting out of the pain much quicker than most. That's what we'd find, right? So it'd be normally distributed. Pretty much everything is. So their first question to us then, that's what all this week, chapter 6, 7 are going to be about. What is the distribution for X? Now, what's that X thing? Well, they're going to just use X to represent whatever it is we're talking about. It could be men's shoe sizes. In this example, it's days to pass the kidney stone. So how is X distributed? Well, that N right there, I don't know if you can see that. There's an N right here. That means normally distributed. And then the parentheses has 2 blanks in it. What are those 2 blanks? They want you to put the mean right here and the standard deviation right there. The middle of the bell curve, that's the mean. And then the average distance from the middle. So the mean is 15 and the standard deviation. You just grab those numbers and pop them in. That's all you do in part A. Just pop. We're just saying it's a normal distribution whose middle is 15 and average distance from the middle is 4. Standard deviation is 4. Question B. Find the probability that a randomly selected person with a kidney stone will take longer than 11 days to pass it. So what's the probability, if you grab somebody at random with a kidney stone, that it's going to be longer than 11 days for that person to pass his or her kidney stone? Now, we're going to do it on the calculator. We're going to hit some buttons. We're going to crank out a brand new function today. But before we do it, it's good to have like a feel, because it's easy to hit the wrong buttons, on the test. Tell me just off the top of your head. The average is 15, right? Remember, that's the middle. The average person takes 15 days to pass their kidney stone. So what percentage of people take longer than 11 days? Do you think? More than 50% or less than 50%? More. Think about it for a second. What's a way I don't think I can make it any simpler. Just think about it for a second. If the average person takes 15 days, right, then that means half the people take 15 or longer, half the people pass their kidney stone 15 or less, right? That's the middle, that's the average. So how many people, for example, take 19 or longer? I don't know, some percentage below 50. Less than half the people, whatever. The calculator will tell us. But I just want you to know ballpark. It's got to be less than 50 that are 19 or more. How many are 11 or more? 11 or more would be all of this. It's got to be more than 50%. Do you feel that as we dive in? The answer has to be more than 50%, because 11's quicker. Right? 11 days is quicker than the average. If you're saying how many people take longer than 11 days, most people do. Right? Because half the people take more than 15 days. So more than half take longer than 11 days, right? So we know, so that's just it's always good to be doing that with yourself because it's so easy just to hit a wrong button. If we hit the buttons and it tells us something like 0.37, we're going to go, no way. I must have hit a wrong button because I know the answer is more than 50, right? It's got to be more than 50%. All right, let's hit the buttons now. What are those buttons? So go to your calculator, and it's the same menu we used last time. Second, the VARS button, which really gets you the distributions. So we're going to go to that same menu where we got the binomial distribution, except this time we're going to take the second one in the list. NormalCDF. No big surprise. Normally distributed, NormalCDF. We're not going to use that top one, NormalPDF, ever. Just the NormalCDF. How does it work? It's got 4 entries. What are they? They are left edge, right edge, mean, and standard deviation. Left edge, right edge, mean, standard deviation. So let's go back here. I'm going to go NormalCDF. Okay, left edge. Now, what do they mean left edge, right edge? They mean the left edge and the right edge, this is the left edge, this is the right edge, of the chunk of shading. So we're on every one of these problems, we're going to draw a bell curve, and we're going to shade a chunk according to what they say. How did I know to shade from 11 to the right? Well, because they said longer than 11. Bigger stuff is to the right, huh? So I went 11 and shaded to the right. If they said less than 11, I would have done 11 and shaded to the left. Is this making sense? So now when I use the NormalCDF on the TI calculator, you put in the left edge of the chunk of shading, which is 11, and then comma, and then you put in the right. Now the right edge, is it 28? No, that's just, the right edge is actually forever to the right. Because that bell curve goes forever right and left. It just gets down so fast it kind of looks like it stops, but it doesn't really. It goes forever left and right. So this is the left edge. The right edge is actually forever. Now, how do you put forever into a calculator? You put in 9999999. Put in a bunch of nines. That means forever to the right. That is forever. 99,999. That's forever. I'm joking around, but then it's good enough for the calculator. So we just throw in 99999. It's just far to right. Okay, so left edge, right edge, and that's just forever to the right. Now next comes, what comes next? Mean and standard deviation. So they told me the mean right there, 15 days, 15 standard deviation, 4. So pop those in your calculator and hit the buttons. I'm going to do it too. I'm getting 0.84. How many decimals they want?
4.
Where does it say that? Oh, there it is. Yeah, 4. 8413. So we expected something more than 50%. Sure enough, that's 84%. So that means this is 84% of the curve. Meaning 84% of the people will take 11 days or longer to pass their kidney stone. That making sense? Yeah, so you'd say it's the same 4 things. Yeah, lower and upper mean left edge, right edge. That's right. And then mean and standard. It's the exact same 4.
The mean on this one will be mu, right?
The mean is mu. And the standard deviation is sigma. That's a Greek S. Is what that. Those are Greek M's and S's for mean and standard. That's all they are. All right, we good? And then there's another part here. There's a question C. Find the minimum number for the upper quarter of the time to pass a kidney stone. Yeah, that's a little tricky. So let's look at the difference in the questions. So let's look now with me at part B. Part B says find the one we just did, right? Part B said find the probability. That means percentage, right? Probabilities are always percentages. Decimals, percentage, same thing. So they're asking, part B, the one we just did, they were asking for a percentage. When they this is on your notes. This is your exam 2 notes I just handed you. This will help you. You can add pictures to it or whatever if you want to. When they ask for a percentage, don't worry about that in. For now, it's all good. We'll do more later. There, you do normal CDF. That's what we just did. Left, right, mean, standard. That's exactly what we just did. But now on part C, notice, they're saying find the minimum number for the upper quarter. In other words, let's draw the curve and I'll show you what they're saying. For part C, remember the middle is still 15. That's still the average number of days it takes to pass the kidney stone, right? And they're saying upper quarter. That's like football game, basketball game, last quarter, right? So that would be like this, and that's 0.25% of the graph, huh? See, they're giving me a percentage, an area, this time rather than asking me for one. That's what this is saying down here. Don't worry. This is going to be chapter 7. That's Wednesday. Don't worry about this. But down here, so this, when they give you a percentage already, that's what they're doing here. They're giving me upper quarter, upper 25%. In other words, they're saying to me, how long does it take people to pass the kidney stones that have the worst 1/4 of it? The upper worst 1/4 of people with kidney stones. That's what they're saying. So they're giving us the area. They're giving us the percentage. When they give you the percentage already, you got to do inverse norm with area to the left, mean, and standard. See the difference? That's what it's going to be about all the way through. They either ask you for the percentage. That's what they did on B right here. They said find the probability. That's find the percentage. Or part C, they give you the percentage. They said, hey, it's the upper quarter, the upper 25%. Okay, so on this one then, we are going to do inverse norm. Let me see if I have room to write it right here. Inverse norm. And it's going to be area to the left. Mean, comma, standard. It's always mean and standard at the end. Okay, well, what does that mean? Let me write it down here. Inverse norm. And that's on your calculator. Same menu. You probably see it right there, right? It's the next one below normal CDF. Inverse norm. Now, you've got to have area to the left. It's just like the binomial thing we did last time. Remember how the binomial thing only dealt with areas to the left? That's all it could do. That's how they programmed it. That's how they programmed inverse norm as well. You always have to give it the area to the left. Now you say, well, look right here. I've got the area to the right. Yes, you do. So you got to change that. The calculator doesn't speak that language. It's like we're speaking English. It wants it in Spanish or some other language, right? We're translating into the language the calculator speaks. And the calculator says, I speak area to the left, please. So if you want an answer from me, you tell me the area to the left of that spot, and I'll tell you the spot. So if you want to know this spot right here, how many days it takes to pass that kidney stone, you tell me this area, and I'll tell you that spot. Make sense? See how that calculator's thinking? That's how he's programmed. He's not thinking. But that's how he was programmed. Area to the left of this spot. That's how he works. Right? Like a vending machine says, put your dollar bills and get your soda out. This inverse norm thing says, give me area to the left, and I'll give you your spot. So that means and they're going to play this game with us throughout tonight's homework. They're going to give us area to the right, or area in the middle, or area to the left. And we're going to have to always change everything to the language the inverse norm calculator speaks, left. So what is the area to the left then? If 25% is to the right, 75. It's not a big deal, right? We just do 1 minus. 75% must be to the left. That's what you put in your calculator. It's got to be area to the left. That's all he speaks. That's all this function speaks. 0.75, the mean is still, 15? Standard deviation is still 4. Hit the buttons on the calculator. I'll do it in 17 point, how many decimals? That's 4 again, I guess? You're getting 17, or is it 2? 4? Okay. 69795. Yeah, hey, maybe I can help you round that. Sometimes I know that can be confusing to round. So that's what I got, but I got to round it to 4 places. How do you, in fact, let me write it up here. 17.69 795. Yeah, you cover. I know sometimes that's hard for people to round. They want the fourth place, so you circle the fourth place. Look one to the right. If the one to the right is 5 or more, you go up. How do you make 79 go up? Right, 6980. There's our answer. Meaning this spot, what does that mean in real life? That means this spot right here is 17.6980. Meaning people that are in the worst 25% of kidney stones, their kidney stone takes 17.6980 days or longer to pass. That's the beginning of the top 25% worst kidney stones, is what that means. So number 2. All right, the average student loan debt for college graduates is $25,350. Suppose that the distribution is normal and that standard deviation is 11,600. Let x equal the student loan debt of a randomly selected college graduate. Round all probabilities to 4 decimal places and dollar to the nearest dollar. All right. First off, what is the distribution? Well, every time you're just going to put the mean here and the standard there. What's the mean? What's the average student loan debt? 25,350. 25,350. All right, so the mean is 25,350, and the standard deviation is 11,600. It's a lot of debt. All right, so now find the probability that the college graduate has between this and this in student loan debt. So let's draw ourselves it's always good to draw the normal curve. Not that we're going to do a lot with it, but it'll kind of guide us. And then put the middle. What's the middle of the normal curve? Yeah, it's always the average, huh? It's the middle. The average student debt is $25,350. We don't need to put the standard on there, but just put the middle. Just draw the bell curve, put the middle on there. Okay, and then put what they're asking on there. What are they asking? Between 23,850 and 34,250. Now, where's the 23,850? Is it left of the middle or right of the middle? Well, the middle's 25, so 23 is a little bit, it's probably not that far, but I couldn't squeeze it in any other way. 23,850 and 34, that's certainly right, more than 25, right? So they're saying find that area in between 23,850 and 34,250. Good on that? That's a picture. I think that'll help you know what to do. All right, can you? Now, so you want to discern, am I going to do normal CDF or inverse norm? Are they asking for a percentage or giving me a percentage? They're saying, find the probability. That's your percentage, right? Find the probability. Percentage decimal, same thing. So they're asking for a percentage. Go back to the notes, wherever they are. There they are. When they ask for a percentage, that's normal CDF. That's the normal thing they do. All right. So we're going to do normal CDF. And we're going to do left edge, right edge. Remember how it works. So left edge, right, comma right edge, comma mean, comma standard deviation. Can you crank that out real quick? Okay, so the left, so what do we mean by left edge, right edge? We mean the left edge of the chunk of shading. This is the left edge, huh? And the right edge of the chunk of shading, don't we? It's what we always mean by that. And so what are those numbers? That's the 23, whoops. Yeah, no, I'm right, 23,850. Don't put a comma in the number because the commas have to go between the left and the right and the mean and the standard. 23,850, that's the left edge right here. The right edge is 34,250. The mean is the 25,350. I'm just running out of room. These are big numbers. And the standard is the 11,600. There we go. Put those numbers in. I got 0.32. No, oh yeah, that's a tricky one to round also. I got 0.32997. Did y'all get that? And then you need to round that to 4 places. Do you know how to round that to 4 places? So you circle the 4th place. You circle the place you're going to stop at. You look 1 to the right, And if the one to the right is 5 or more, you go up. So how do you take 3299 and go up by 1? 3,300, right? 3,300, point 3,300 is just above point 3299, isn't it? Is that good for that? That means this is 33%. You know, 0.33, that's 33% of all students come out with a student loan between 23,850 and 34,250. That's what that means. See how just by knowing the middle and the standard and that it fits a bell curve and having the calculator, we can crank out exact answers. We know the debt of 33% of all the students, somewhere between 23,850 and 34,250. All right, how about question C? Questions on that so far? Is that good? Question C now is going to be more tricky. Find the middle 30% of college graduates' loan debt. Lies between what two numbers? Maybe a fresh screen would help. Well, here, let's put it on a fresh screen here. Okay, so middle 30%. So I'm going to draw a bell curve. And here's the middle, which is whatever it is, 25,000. So you always put the middle on there. Always put the middle. That'll help you. 25,350. And then we want to find the middle 30%. Point 30, right? Or 30%, however you want to write that. I'll just do the decimal. Either way is fine. Mine doesn't look even, Steven. It's supposed to be. There we go. That looks a little better. Anyway, good so far? That's what they're talking about, right? They want me to find this edge and this edge. That's what they're asking. They're saying, what two dollar amounts surround the middle 30% of student loan debt? What is this number and what is that number? From where to where is the middle 30% of student loan debt? That's what they're asking. Okay, so first off, are we talking about normal CDF or inverse norm? Are they giving me a percent or asking me for a percent? Oh, yeah, this is a tricky one. No, that's right. No, yeah, exactly. You guys are right on track. And my method's working fine. They're giving me a percent. They absolutely are. They're giving me that 30%, aren't they? So go back to the exam 2 notes. When they give you a percent, inverse norm, huh? Now, I want to caution you. There's a difference between homework and an exam. I'll just tell you right now, every one of these homeworks, Part C is going to be inverse norm. Every time. It's going to be inverse norm. So pretty soon your brain can go off, right? Part B is always going to be normal CDF. So pretty soon you can be doing it on autopilot, but on test day, 9 days from now, when I hand you that exam, it won't be so obvious. They'll be all mixed up, and it'll just be words. It'll be Part C all by its own self, not right next to the one right before that was just so. So make sure you really know it out of context. That's why I give you that practice exam. Because you know what I mean? Homework, you can just we do the same thing 10 times in a row, so you know it without really knowing it out of context, right? So make sure you don't fool yourself, because the truth will come out 9 days from now about how much you really know these things out of context. So that's why I say practice that. Even now it's available. This weekend I'd encourage you to look at that price down. The mix-up's what's challenging. All right, so yeah, it's inverse norm. Without even thinking, it's inverse norm. They're giving me the percentage. Okay, so what do I have to do for that thing? Area to the left, mean standard deviation. Okay, so that's how he works, right? He says, you give me the area to the left, I'll give you the spot you're looking for. That's how he works, right? You give me the area to the left. He's like a vending machine. You give me the dollar, I give you the soda. You give me area to the left. Yeah, okay, 30%. No, that's not area to the left, is it? So what are we going to give him? Well, it's going to be two separate issues. First off, we got to find this spot. What is the area to the left of this spot? This spot. How much area must be to the left of that spot? Beautiful. How'd you come up with that, Zach?
It's 15 to the left and 50 to the right, or the 30 in the middle. So then just take 15 off of the 50 that was going south.
Okay, I think I can say it a little simpler, but that was a good job. It might be easier for people if I just said, look, if 30% is there, what's missing? 70%, right? Just 1 minus 0.30. 0.70 is missing, which means this and this together make 0.70. What's missing? They're even Steven, right? It's right in the middle, so those two parts are equal. So what do I do to find what each of them is? If both together make 70%, how much is each? Just divide it by 2, huh? 0.35. This must be 0.35. This must be 0.35. That's 100% now. That makes sense? Right? Because 35 and 35 make 70, and 30 more make 100. Everybody see what I did there? I just subtracted from 1 to say 70% is missing and cut it in half because it's in 2 pieces. It's in 2 empty spots. Got 35% to the left and 35% to the right. Good there? There's other good ways, but that's one way. So when I do the inverse norm thing then, how am I going to do it? What am I going to put for area to the left? Well, 0.35. And the mean is 25,350. And the standard deviation is 11,600. So put that in to the calculator. Getting change the color here. 20,000. What is that? 880.
Yeah.
20,880, and they want to the nearest penny or just dollar? It's dollar, I think. Yeah, nearest dollar. So 20,880. Boom. So that means this spot here is 20,880. So we got that spot. We got the left edge. But now, somehow, we need to come over here and get the right edge. We got to do another inverse norm to get the right edge. Inverse norm, right? To get this spot right here, we got to do another inverse norm. And the first thing you got to put in here is area left. So so the question always becomes, what's the area to the left of this spot? 65, right? Isn't it 30 and 35? It's 65.65. Comma mean, whatever the mean is, 25,350. Standard 11,600. Hit the buttons on the calculator. Getting 29,819, but it rounds up to 820, doesn't it? $29,820. So the middle 30% of college students have loan debt between $20,880 and $29,820. How are we doing? Okay, so here's number 3, which is really very similar. Suppose that the distance of fly balls, it's almost October, which means baseball playoff time. Suppose that the distance of fly balls hit to the outfield in baseball is normally distributed with a mean of 257 feet and standard deviation of 37 feet. So what is the distribution? Same thing, you just always put the mean and the standard. The mean is 257, standard is 37. So that means a normal distribution with the middle at 257, standard at 37. Next question, find the probability that a randomly hit fly ball travels less than 317 feet. So good to draw a normal curve. I think it's helpful. So draw a normal curve. Put the middle on. The middle is 257 feet, the average fly ball. What are we doing with probability less than 317 feet? So where's 317? Is it to the right or left? Is it greater or less than 257? It's greater, clearly greater. It's somewhere over here. It doesn't matter how far, just as long as you know it's to the right, you know? And that's 317. Now, which direction am I supposed to shade? What does it say? Less than 317. Where's lesser stuff, right or left? To the left. So I'm supposed to shade left of 317. Does that make sense? How we're coming up with that? So there's the chunk we're supposed to find. There's the area we're supposed to find. Is the answer going to be more or less than 50%? That's clearly more than half the curve, isn't it? More than 50%, yeah. All right, so it's going to be, again, they are asking me for the probability. That means it's normal CDF. So for normal CDF, you do left edge, right edge. What's the left edge of that chunk of shading? The left edge is way over here. The right edge is right there, huh? So what's the left edge?
0.
No, it's left forever. Remember the curve goes down forever? That's why I talked about Google. Google's 1 with 100 zeros, right? So it goes forever. It goes Google both directions. It goes forever both directions. But forever to the right, I said just put in .999, or not point, sorry, positive 99999. So what's forever to the left? Yeah, you just put in negative and a bunch of nines. So left forever is just negative 5 or 6 nines. Does that make sense? That's how we tell the calculator left forever. The shading goes from left forever up to 317. From a left edge of left forever, negative 99999, up to a right edge at 317, comma mean, comma standard. The middle is 257. Standard deviation is 37 feet, they said. Hit the buttons on your calculator. Answer is, what is it, 94755, so rounds to 6. So in other words, that's 94% of the curve, or almost 95%, is what that means. 95% of fly balls go 317 feet or less, is what that means. Good with that? And then part C, find the 70th percentile. Remember how percentiles work? We dealt with that in the last part of the course, right? Remember percentile? That's just if you had a big long line, that's just a ranking by percentage. You could start out at 0 here and goes all the way to 100. 50% is 50 percentiles halfway through, right? So that could be a ranking for fly balls. So we're just saying, hey, if we ranked all fly balls and how far they went, here would be the shortest fly balls, and then the longer, all the way up to 100% would be the longest fly balls. So we're just, and they're saying, find the 70th percentile. Where's that going to be? Yeah, about right there. 70 percentile is right there. In other words, it's 70% of the way along in a listing of all the fly balls. That makes sense? That's what percentile always is a percentage ranking from 0 to 100. So they're saying, find how far is the 70th percentile fly ball. In other words, tell me how far fly balls go so it's further than 70% of other fly balls and 30% go further than it. That's another way of saying that. Does that make sense? They want me to know, or they want me to figure out how far a fly ball goes at the 70 percentile mark. In other words, further than 70% of fly balls hit, and shorter than 30% of the other fly balls, of the longer fly balls hit. Okay, so what then? What do you do with that? Well, I've already told you, part C is always going to be an inverse norm. But would you know that if this question was isolated all by itself 9 days from now on the exam? Because that's the way it'll be on test day. That's how you really know something, not when you can just do it because you know what section you're in. But a real life question, could you answer that? Would you realize that's an inverse norm? Let me get you a fresh screen here. So you always want the bell curve. And let's put the middle on there. The middle is 257. And they're saying the 70 percentile. Well, they're giving me a percentage, aren't they? So remember what we learned back from the notes, somewhere back here, that when they give you a percentage, that's inverse norm. So that's how you'd recognize it. You can recognize it on the exam. If you have that notes before you, you will, right? Think, oh, they're giving me a percentage. So I've got to do inverse norm. And let's put it on the curve. Is it going to be is it going to be right of the middle or left of the middle? It's got to be somewhat right of the middle. I don't know what the spot is, but I know that all this is 0.70. It's 70%, isn't it? The area to the left of that spot is 70%. 70% of all fly balls are whatever that distance is and below. Is that making sense? So that's inverse norm. Remember how it works? What do we put in here first? Area to the left, and then mean, comma, standard. So what's the area to the left of this spot? Do I need to do 1 minus? Or is 0.70 just straight out the area to the left? Yeah, look at the picture. That's the area to the left. So this time, no translation. We're already speaking in the right language. Does that make sense how we didn't need to translate? We're already speaking in the correct language. That already is area to the left, isn't it? Comma mean, what's the mean? 257, comma standard deviation, 37. There we go. Hit the buttons on the calculator. I'm getting, what does it want me to, 4 decimal places. 276.4028. So that means this spot right here is a fly ball hit 276.4028 feet. So any fly ball hit 276.4028 feet or less is at the 70 percentile mark, meaning 70% of all fly balls are hit at 276.4028 feet or less. Oh, there we go. There's a statistic. 276 feet or less. 70% of fly balls. We good there? Oh, I put that in the wrong blank, didn't I? That should go down here. We already did part B. We're done with part B. There we go. Okay, so number 6. The patient recovery time from a particular surgical procedure is normally distributed with mean 4 days, standard deviation 2. Let X be the recovery time, blah, 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 blah. So you know what we do here? We put the mean and the standard deviation. The mean is 4 days, standard deviation 2. That's a normal distribution. What is the median? Median, what's the median? It's the middle. Whether you call it mean or median or whatever, it's going to be the same thing, isn't it? It's going to be the 4. It's the middle. It's the middle. Let's keep going. What is the Z-score for a patient who took 5.1 days to recover? You remember? Yeah, good memories. Anybody else remember the Z-score formula? Probably not. I'm assuming you just put it on that sheet and used it for the test. Z-score is mean. No, I don't remember it either. Score minus mean, isn't it? Yeah. Score minus mean. Mean over standard deviation. Yeah, it's been a while since that was in the first part of the course. And honestly, I'm not going to give you a Z-score question on your exam next week. Don't worry about it. You don't need to put it on that sheet. But let's get through this homework problem. So, score, so that's the 5.1 days, minus the mean, which is 4, over the standard deviation to 2. Hit the buttons on your calculator. It'll be 1.1 divided by 2. So whatever the calculator says. 0.55 on that. So that was kind of out of the blue. Again, that will not be on exam 2. What is the probability of spending more? Now we're back to normal questions. What is the probability of spending more than 3.3 days in recovery? What's the chance of that? We good? Let me jump in and do this one with you. So for part D, we got to draw ourselves a normal curve. And you put the middle. What's the middle? 4. The middle is the mean is 4. The average recovery time from this surgery is 4 days. And they're saying, what's the probability of spending more than 3.3? So how do we do this? We put, where's 3.3? Is that more than 4 or less than 4? So it's going to be over here to the left. Now, do we shade to the right of that or the left of that? What did they say? More. More is to the right. More than 3.3 is shading to the right of 3.3, huh? So that looks like an answer that's more than 50%, huh? That's more than half the curve. So we're expecting an answer more than half the curve. We'll do the normal. There's never any room here. So I'll do it right here, I guess. We're going to do normal CDF. And what do? We do left edge, right edge. So left edge, right edge. So the left edge, 3.3. What's the right edge? Yeah, left edge. The right edge is over here, which will be 999, huh? Bunch of nines. It's infinitely to the right. So a bunch of nines. And then mean and standard, like usual. Mean is 4. Standard deviation is 2. Hit the buttons on your calculator. I'm getting 0.6368. So in other words, there's a 63% chance, or almost 64, that your recovery time is going to be 3.3 days or longer. Because most people have a recovery time. 63% of the people, or about 64%, have a recovery time 3.3 days or longer. Question, are we good there? Questions on that so far? D, what is the probability of spending 3.4? That'd be easy. Let's skip it. Let's go to F, the 80th percentile. How would we do 80th percentile? Can you do that one real quick? I'll give you a second. All right, are we good? I'm going to jump in there. For this one, again, you want to draw the normal curve, put the middle on there, 4 days, average recovery time. 80th percentile. So remember what percentile is, a ranking from 0 to 100. So 80%, and that's a percentage. So clearly there, you would recognize this on the exam in 9 days, right? You'd see it and you go, oh, they're giving me, you go back to the notes here. You'll have these exam 2, we're not in exam 4 yet. Exam 2 notes before you, and it would say, hey, they're giving me a percentage. They're giving me 80%. So, I got to do inverse norm. So you'll be able to recognize that if you have those notes. So you go, okay, so it's just inverse norm. And where is the 80%? 80%, is it past the middle or before the middle? Yeah, it's got to be somewhere here. And the percentage, 0.80, is, so we're looking for the spot. It's going to be more than 4 days, right? That's the 80 percentile recovery point, right? What's the spot, which is 80% along the way for recovery time? So inverse norm, area left, comma mean, comma standard. So what's the area to the left?
80%.
It's just the 80%. That is to the left, isn't it? And the mean, so we didn't have to do anything fancy. The mean is 4, standard is 2. Hit the buttons, you got it. It's getting easy? Getting to be the same thing every time? Questions I can answer on that? Okay, so I'm going to stop there at number 6. The rest is 7 and 8 are the same.